Hello everyone, welcome to IB Math Solution. Today we'll be studying about interval notation. So we'll start with the exercise questions. First question says, for the following sets, write down the meaning of the interval notation. Now, part A is equal to this thing. Now, what does this mean? Interval notation means A is the set of all x such that, now this symbol here, it means such that x is an integer between -1 and 7, including both -1 and 7. This is what we mean by interval notation. Now, we have done the first part. For second part, the question is asking, if possible, list the elements of A. So, the elements of A will be -1, 0, 1, 2, 3, 4, 5, 6, and 7. Now part C says, find number of elements in A. So number of elements in A is 1, 2, 3, 4, 5, 6, 7, 8, 9. That will be 9. This is our answer. Now part B says, A is equal to now we know n is a set of all natural numbers, that is 0, 1, 2, 3, 4, 5, and so on till infinity. Therefore, set A, we can say A is the set of all x. A is the set of all x such that x is a natural number between -2 and 8, and none of them is included. Why? Because we do not have an equal sign here. Therefore, this part 1. For part 2, we need to list the elements in A. So, the elements of A will be a subset from n that will be between -2 and 8. Therefore, n starts from 0. So the elements will be 0, 1, 2, 3, 4, 5, 6, and 7. Part 3 says, find the number of elements in A. The number of elements in A is 1, 2, 3, 4, 5, 6, 7, and 8. This is our answer. A Now, when we do not have anything like n in this case, we just mean real numbers. So, this same statement can be written as A is a set of x, where x is an element of real numbers and x is between 0 and 1, both included. Now, for part 1, the notation means A is the set of all x such that x is a real number between 0 and 1, including both. Now, part 2 says, if possible, list the elements of A. Now, here, what are real numbers? Real numbers are those numbers which can be written in decimal forms. So, between 0 and 1, how many real numbers are there? We know 0.00001 is a real number. We know 0.00035 is a real number. We also know 0.015 is a real number. We know 0.15 is also a real number. So there are infinitely many elements in this set. Hence, it is not possible to list the elements of A. Now, part 3 is asking the number of elements in A. Since there are infinitely many elements in A, therefore n of A is undefined. Now, part D, the meaning of this interval notation is A is the set of all x such that x is a rational number between 5 and 6, including both. Now, the elements of A are of the form P by Q, where P and Q both are integers. Therefore, we can say A is the set containing 5 divided by 1, 11 divided by 2, 16 divided by 3, and so on, infinite number of elements. As long as the whole number is between 5 and 6 till 6 divided by 1. Hence, we can say it is not possible to list all the elements of set A. And similarly, part 3, number of elements in A is going to be undefined. This is our answer. Let's move on to the next question. Now the question says, represent on a number line. Part A, a set of all x such that x is an integer, x is a positive integer less than or equal to 5. So let's create a number line, and here we have 0, 1, 2, 3, 4, 5, 6. So a set of all positive integers, that means it will start from 1 and less than equal to 5 and will end here. Therefore, all the numbers 1, 2, 3, 4 and 5. This is our answer. Part B says, a set of all x such that x is a natural number less than 5. Points will be 0, 1, 2, 3 and 4. This is our answer. Part C, a set of all x such that x is an integer greater than -2 and less than 3. The integers greater than -2, that means from -1, 0, 1 and 2, and less than 3, that means 2. So this is our answer. Part D, a set of all x such that x is a positive integer greater than 3 and less than or equal to 7. The integers greater than 3, that will start from 4, 5, 6 and less than or equal to 7. So that will go to 7, and this is our answer. Now, a set of all x such that x is a real number greater than or equal to 3. So when we say in case of real numbers, if it is also equal to 3, then we make a dot and fill it. And if we do not have a boundary, then we make this arrow. This is our answer. In this case, a set of x such that x is a real number less than 6. This line will also start from 6, but this dot will be empty inside because we do not have to consider 6. It has to be less than 6. Now this arrow will be leftwards, and this is our answer. Now you see the difference. When we had x greater than or equal to, when we had this equal to, we filled this dot. When we do not have this equal to, we do not fill this dot. Similarly, this is your homework. Now let's do question 2 part I. A set of all x such that x is a real number. Here we do not have anything, that means it is real numbers we are talking about. So a set of all x such that x is a real number less than 3. So on number line we'll have 3 somewhere over here. Union a set of all x's such that x is a real number greater than 6. And we'll have 6 somewhere over here. Now in this case we are supposed to make lines for these two conditions. So what is this condition? This condition will be an empty dot and an arrow towards left. And for this condition, an empty dot and an arrow towards right. So this is our answer. For part J, it says a set of all x is that x is a real number less than or equal to 2. So we have 2 somewhere over here and we have 4 somewhere over here. So to plot it, we know x is less than or equal to 2. So we'll make a dot and fill it from inside. And x has to be less than or equal to 2. So this arrow will be leftwards. Union a set of x such that x is a real number greater than 4. Now here at 4 we'll make an empty dot and an arrow towards right. This is our answer. Now you can do this part. This is your homework. And let's do part L. Part L says a set of all x such that x is a positive integer less than or equal to 6. Now positive integers start from 1, 2, 3, 4, 5, 6. Positive integer less than or equal to 6. So we have all these points. Union a set of all x such that x is a positive integer between 8 and 11 including both of them. So we'll extend this line. This is 7, 8, 9, 10, 11, 12, and these points will be 8 to 11 both including 8, 9, 10 and 11. So this is our answer. Let's move on to the next question. Write in interval notation. So we know when we have an arrow, we mean real numbers. So in this case, A, it is a set of all x such that x is greater than or equal to 8. This is our answer. Part B, now we have a line, continuous line. That means we are talking about real numbers. Therefore, a set of all x such that x is greater than or equal to -1 and less than 4. This is our answer. Here, now we know we have integers over here. We do not have natural numbers because natural numbers start from 0. But we also have dots here at -1 and -2. That means we are talking about integers. So here it is a set of all x such that x is an integer and x is greater than or equal to -2 and less than or equal to 3. Or this same thing can also be written as a set of all x such that x is an integer and x is greater than -3 and less than 4. So they both mean the same thing, depends on what you want to write. Part D says, now we again have a line with an arrow, so we mean real numbers. A set of all x such that x is less than -5 union a set of all x such that x is greater than 1. Now this is the answer. Similarly, all these you can do on your own and it is your homework. Let's move on to the next question. State whether A is a subset of B. So in part A is an empty set. So we know an empty set is a subset of every other set. Therefore, for part A, the answer is yes. Yes, A is a subset of B. For part B, is A a subset of B? No, rather B is a subset of A. So the answer is no. Part C, here we need to plot it on a number line and we can check after that. So part C says A is a set of all x such that x is a real number between 2 and 3 both inclusive. So the number line, this is 2, this is 3, here we have 1 and here we have 4. So there will be a line segment between 2 and 3 including both. Now B says it is a set of all x such that x is a real number. Therefore this is A and this is B. Now can we say A is a subset of B? Yes, we can say A falls on B. So yes, A is a subset of B. Now part D. Now let's plot it on a line. A is a set of all x such that x is a rational number between 3 and 9 both, including both. So B is a set of all x such that x is a real number between 0 and 10 including both. Now we know that real number contains everything. So this is real numbers and we know B is from 0 to 10. So if we talk about number line and we have 0 here and 10 here, this will be our B. This is our B. What about A? A will be all rational numbers between 3 and 9. So 3 will be somewhere over here, 3 will be over here and 9 will be here. So we know all the numbers between 3 and 9 won't be rational numbers. There will be some numbers which will be rational but not all. Therefore, let's represent it with this dotted line, and we can say this is set A. Now, can we say this set A will lie on B? Yes. So, the answer to the part D is yes. Part E says A is a set of all integers such that those integers are between -10 and 10. Set A will be this set. So this will be set A. And set B will be a set of all integers from 0 to 5, including both of them. So 0 to 5, 0, 1, 2, 3, 4, and 5. This is set B. Is set A a subset of set B? No, rather B is a subset of A. So in this case, the answer will be no. Similarly, part F is your homework. Let's move on to the next question. Find the complement of C given universal set is Z. Now, what is Z? Z is a set of all integers. And U, universal set, is equal to Z. Also, C is a set of all x such that x is an integer less than or equal to -5. Now, subset C is and all other points over here. So what will be the complement of C? The complement of C will be all the points on the right side of -5. So this will be complement of C, where we know this is C. So we can write complement of C is a set of all x such that x is an integer greater than -5. This is our answer. Now part B says universal set is Q. That means a set of all rational numbers. And C is a set of all x such that x is a rational number less than or equal to 2. Union a set of all x such that x is a rational number greater than or equal to 8. Now, Can we say complement of C will be everything which is not C? So C is all rational numbers less than or equal to 2 and all rational numbers greater than or equal to 8. So C complement will be all rational numbers between 2 and 8. This is our answer. Let's move on to the next question. Suppose universal set is a set of all integers such that those integers are between 0 and 8, including both of them. And A is a set of all integers between 2 and 7, including both of them. And B is a set of all integers between 5 and 8, including both. List the elements of A. So let's first draw a number line. And we have different points. So the key points are 0, 8, 2, 7, 5 and 8. So let's start with -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. This is X. Now we have U in this color, that is universal set, which is all integers between 0 and 8. Let's say A is in this color. So A will be all the integers between 2 and 7, both included. And set B in this color, which is all integers between 5 and 8, both included. Now the question is asking list the elements of A. So A is a set 2, 3, 4, 5, 6 and 7. A complement will be all other elements of U apart from A. So that will be 0, 1 and 8. Part C is the elements of B. The elements of B are 5, 6, 7 and 8. 5, 6, 7 and 8. The elements of B prime. So the elements of B prime are the elements of U not present in B. That will be 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. Part E, A intersection B. Now this is A, this is A, this is A, this is B. So A intersection B is where both of them are present. That will be 5, 7 and 6. So 5, 7 and 6 is A intersection B. Part F is A union B. A union B will be where at least one of either A or B are present. That will be A union B. So that will be 2, 3, 4, 5, 6, 7 and 8. 2, 3, 4, 5, 6, 7 and 8. Part G says A intersection B prime. A intersection B prime. So what is B prime? B prime is this part, and A is this part. So what is the intersection of these two parts? That is 2, 3 and 4. 2, 3 and 4. This is our answer. Let's move on to the next question. Suppose universal set is a set of positive integers and P is a set of all positive integers such that they lie between 9 and 16, including 9, and Q is a set containing 2, 4, 5, 11, 12 and 15. List P. So first we need to list U, and that will be a set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. The elements of P will be 9, 10, 11, 12, 13, 14 and 15, and the elements of Q are 2, 4, 5, 11, 12 and 15. Now the question is asking in part A, list P. So we have done it already. Find P intersection Q. Now P intersection Q will be 11, 12 and 15. C is P union Q. P union Q will be 2, 4, 5, 11, 12, 15, 9, 10, 13 and 14. Part D says, show that number of elements in P union Q is equal to number of elements in P plus number of elements in Q minus number of elements in P intersection Q. So let's write this equation first. From here we can see number of elements in P union Q is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we can write it as 10. Number of elements in P is 1, 2, 3, 4, 5, 6, 7. 7. Number of elements in Q is 1, 2, 3, 4, 5, 6. And number of elements in P intersection Q is 1, 2, 3. This is 3. 7 plus 6 is 13 minus 3, that is 10. So left hand side is equal to the right hand side. Hence shown. Let's move on to the next question. Suppose universal set is a set of all x such that x is an integer and is between 0 and 40, including both of them. P is a set of factors of 28 and Q is a set of factors of 40. So this question can be done the very same way we have done question number 8. We need to write the elements in the universal set. So that will be 0, 1, 2, 3, 4 till 40. Now P, the factors of 28 are 1, 2, 4, 7, 14 and 28. The factors of 40 are 1, 2, 4, 5, 8, 10, 20 and 40. Therefore, now we have listed all the sets. So this question now can be done the very same way we have done question number 8. Let's move on to the next question. Suppose universal set is a set of all integers between 30 and 60. So U is a set containing 31, 32, 33 and so on till 57, 58 and 59. M is a set of multiples of 4 between 30 and 60, that will be 32, 36, 40, 44, 48, 52, 56. That's it. And N is a set of multiples of 6 between 30 and 60. So that will be 36, 42, 48, 54. Yeah, that's it. Now we have already listed M and N. We can also find M intersection N and M union N. So this question is nothing new. We have already done these kinds of questions. This is your homework. Let's move on to the next question. Suppose universal set is a set of all integers. R is a set of all integers between -2 and 4, both included. And S is a set of all integers between 0 and 7, 0 included. List R and S. This is again your homework. We have done many questions like this. Let's move on to the next question. Suppose universal set is a set of all integers. C is a set of integers between -4 and -1, both included. And D is a set of integers between -7 and 0, -7 included. This is again your homework. We have already done these kinds of questions. Let's move on to the next question. Question number 13. Suppose universal set is a set of all positive integers. So U is a set of 1, 2, 3, 4, 5 and so on. E is a set of all x where x is an integer between 5 and 17, including both of them. So P is equal to a set of 5, 6, 7, 8, 9 and so on till 14, 15, 16 and 17. Q is a set of all x such that x is an integer between 10 and 20, including both of them. So Q is 10, 11, 12, 13, and so on till 18, 19, 20. And R is a set of all integers such that they exist between 15 and 23. So R is equal to a set of 15, 16, 17, and so on till 21, 22, 23. So question says, part A, list the sets P, Q, and R. So this is part A. Part B says, find P intersection Q. P intersection Q is equal to the number L. P intersection Q is equal to a set containing all the numbers that are common in P and Q. So what are the numbers? The numbers are 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 in P, and 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 in Q. So the common part is from 10 to 17. That means P intersection Q is 10, 11, 12, 13, 14, 15, 16, and 17. P intersection R, that will be common part in P and R. That will be 15, 16, and 17. Part 3 says Q intersection R. That will be the common part in Q and R. So that is 15 to 20. So 15, 16, 17, 18, 19, and 20. Part 4 says P union Q. P union Q. That will be everything in P and Q written once only. So that is 5, 6, 7, 7, 8, 9, 10, and so on till 15, 16, 17, 18, 19, and 20. Part 5 says P union R. P union R is everything in P and R written only once. So that will be 5, 6, 7, and so on till 21, 22, 23. Part 6 says Q union R. Q union R will be 10, 11, 12, and so on till 21, 22, 23. That is part B. Now part C, subpart 1 is P intersection Q intersection R. P intersection Q intersection R. That will be the common part that exists in all of the P, Q, and R. So the common part of P and Q is from 10 to 17, and then intersection with R will be 15 to 17. That will be 15, 16, 17. Subpart 2 says P union Q union R. So P union Q union R, that will be everything present in P, Q and R written only once. So that is going to be from 5, 6, 7, 8, 9 till 11, 21, 22 and 23. This is our answer. Let's move on to the next question. Suppose U is the universal set containing all positive integers, and that will be 1, 2, 3, 4, 5, 6 and so on till 37, 38 and 39, because x is less than 40. A is a set containing multiples of 4 less than 40. So that will be 4, 8, 12, 16, 20, 24, 28, 32, 36. That's it. Set B is multiples of 6 less than 40. That will be 6, 12, 18, 24, 30, 36. And C is multiples of 12 less than 40. So multiples of 12 are 12, 24, 36, and that's it. So the question says list the sets A, B and C. So this is part A. Part B, find A intersection B. That will be common elements from A and B. So that is 6 is not present here, 12 is present. A intersection B is 12, 18 is not present, 24 is, 30 is not present, 36 is. Second part is B intersection C. That will be common part between B and C. So 12 is present, 24 is present in B, 36 is present. So that will be 12, 24 and 36. So part 3 says A intersection C. That is 12 is present here, 24 is present here, 36 is present here. So this is 12, 24, 36. So part 4 says A intersection B intersection C. So 12 is present here and here. So 12 will be a part. 24 is present here, here and here. So 24 will also be a part. 36 is present here, here and here. So all the three elements. So part 5 says A union B union C. A union B union C. That will be all the elements at least once. So starting from 4, 8, 12, 16, 20, 24, 28, 32, 36, 6, 12 we have already done, 18, 24 we have already written, 30 and 36 we have already written. So that's it. This 12, 24 and 36 we have already written. So now part C says show that number of elements in A union B union C is equal to this whole term. So let's write this term. Number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection C. So from here we can write the number of elements in A union B union C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Number of elements in A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Number of elements in B is 1, 2, 3, 4, 5, 6. Number of elements in C is 3 minus number of elements in A intersection B, that is 3, minus number of elements in B intersection C, 3, minus number of elements in A intersection C, that is 3, plus number of elements in A intersection B intersection C, that is 1, 2, 3. So from here we can say this 3 will cancel this 3 and this 3 will cancel this 3. So 9 plus 6 minus 3, that is 12. Therefore, we can say the left hand side is equal to the right hand side. Hence, we have shown it. Let's move on to the next question. Suppose universal set Q is a set of all positive integers less than 31. Therefore, U will be 1, 2, 3, 4, 5, and so on till 29 and 30. Similarly, A is a set of multiples of 6 less than 31. So A is equal to a set of 6, 12, 18, 24, and 30. And B is a set factors of 30. So it will be 1, 2, 3, 5, 6, 10, 15, and 30. And C is a set containing prime numbers less than 30. So prime numbers less than 30 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now, part A says list the sets A, B, and C. So this is part A. Part B says find A intersection B. So A intersection B will be 6 is present here, 12 is not present, 18 is not present, 24 is not present, and 30 is present. So 6 and 30. So part 2 says B intersection C. That will be common part. So 1 is not present here, 2 is, 3 is, 5 is, 6 is not, 10 is not, 15 is not, and 30 is not. So 2, 3, and 5. So part 3 says A intersection C. That will be 6 is not present here, 12 is not present, 18 is not present, 24 is not, 30 is not. So this will be an empty set, or So part 4 says A intersection B intersection C. So the common part will be an empty set. Since A intersection C is an empty set, so A intersection B intersection C will also be an empty set. Part 5 says A union B union C. This will be six, 12, 18, 24, 30, 1, 2, 3, 5, 6 we have already taken, 10, 15 and 30 we have already taken. Then 2, 3 we have already taken, 5 taken, 7, 11, 13, 17, 19, 23 and 29. Part C says show that number of elements in A union B union C is equal to number of elements in A plus number of elements in B plus number of elements in C minus number of elements in A intersection B minus number of elements in B intersection C minus number of elements in A intersection C plus number of elements in A intersection B intersection C. So this is what we have to show. So going ahead, we know A union B union C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So 18 is equal to number of elements in A is 1, 2, 3, 4, 5. Number of elements in B is 1, 2, 3, 4, 5, 6, 7, 8. Number of elements in C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of elements in A intersection B, that is 2. Number of elements in B intersection C, that is 3. Number of elements in A intersection C, that is 0. Plus number of elements in A intersection B intersection C, that is 0. So negative 2 and negative 3 will make negative 5. So this 5 will cancel these two out, and hence we'll be left with 18 on the right hand side, and hence the left hand side is equal to the right hand side, and hence shown. That's it for this exercise. I'll see you in the next session.